My name is Julie Rogers. I was a teacher at Mangum Elementary School in Richland Parish. My greatest passion as a teacher is to guide my students into realizing their full potential and to challenge them to think and perform outside of the norms that have been placed on them by the status quo. The students in this video are in 4th grade, and the content of this video is science. This lesson is Lesson 4 from Unit 4, Vision and Light, from the Amplify curriculum. The objectives of this lesson are to create models of what animals with different receptor sensitivities might see under the same light conditions, and to discuss what causes animals to see differently. In this unit, students take on the role of conservation biologists, in which they work to figure out why a population of tokay geckos has decreased since the installation of new highway lights in the rainforest. Students use their understanding of vision, light, and information processing to figure out why an increase in light in the gecko's habitat is affecting the population. At the end of the unit, students will turn their attention to humans by designing their own investigations in order to learn more about how our senses help us survive. Prior to this lesson, students have done a lot of work with the standards. In Chapter 1, students figure out that in order to survive, a gecko must avoid predators and find prey. To do this, geckos use structures to get information from their environment. For instance, a gecko uses its ears to hear if there's a predator nearby, and its vision to watch for predators. In order to figure this out, students do hands-on investigations with their own senses to figure out how that they get information from their own environment. Then they read about animals and how they use their senses to find food. In Chapter 2, students figure out that light travels from a source to the gecko's prey. Then it reflects off the prey into the gecko's eyes. And while moving from the prey to the gecko's eyes, it carries information. To figure this out, students use the vision and light simulation to explore the path of light from the source to an object to an animal's eye. They also confront several misconceptions about the role of light and vision by improving inaccurate models of how light reaches the eye. In Chapter 3, students build on what they have learned so far by learning that light, when it enters the eye, it goes to the pupil, and then it goes to the light receptors. The light receptor's job is to respond to the light and send the information from the light to the brain. The brain is what processes that information and forms an image, and by comparing that image to your memories, geckos can recognize what it's looking at and make good decisions that will help them survive. To figure this out, students return to the simulation, where they investigate how a predator knows whether it's looking at a prey or if it's looking at something that's toxic to eat. And they also read the Handbook of Animals' Eyes. And then in Chapter 4, where our lesson comes from, students are investigating this question: how could more light at night make it hard for a tokay gecko to see its prey? In Chapter 4, they figure out that since the highway lights were installed in the rainforest, there is much more light at night. Tokay geckos have light receptors that form clear images in very low light conditions. So the extra light at night makes it difficult for them to form clear images of their prey. To figure this out, students read informational text about different animals with different light receptors, as well as using the simulation and a digital modeling tool to compare the vision of nocturnal and diurnal animals in differing amounts of light. They build physical models of nocturnal and diurnal eyes to help them explain the role of light in vision and survival. There are several things that I had to do beforehand in order to get ready to teach. My classroom is a very student-centered classroom where the learner is at the forefront of learning. They are all expected to participate in discussions, in group work, in experiments, or anything that we're doing. Every student is expected to participate. Therefore, my groups are built as such that students of varying abilities are grouped together. Classroom norms and expectations are also in place so that students take the initiative in all of our activities. There are also several formative assessments in the form of on-the-fly assessments and critical junctures, which enable me to take the pulse of my class and to monitor and support students' progress throughout the unit. These built-in moments have allowed me to adjust instruction as needed and to reteach so that my students are ready for the content and the objectives of this lesson. One thing you should know about this classroom and these students is this: this classroom is actually not mine anymore. and these students belong to Miss Kristen Armstrong. Miss Kristen was my resident in the 2020-2021 school year, and as a result of her hard work and dedication to our students, she was actually hired to take my spot when I took the job as the district literacy coach in Richland Parish. This lesson, the title is Preparing to Build a Model. Now, you guys all year have built some models. Who builds models in life? You don't have to raise your hand. Somebody tell me.
Engineers.
Scientists and engineers do. And so, this unit, you are a what?
Engineer.
You are. And you are getting ready to do stuff to release your report back about your geckos. Let's talk about your phenomena in just a second. The tokay gecko is going extinct, and we don't know why, right? We're trying to figure out why this tokay gecko is possibly going extinct, and it's your job to figure it out. And today, this model that you're going to do is going to be very, very important. Notice it says preparing to build one, because you can't build one yet. You've got some learning to do to get to the place where I need you to be to build a really good model. Okay, so let's dig in. Okay, this is the investigation question that you've been doing. Why do different animals need different amounts of light to see well? And you guys have been learning about this through reading, through simulations, through the modeling tool. Okay, please remember those three things that you've been doing, because all three of those things are evidence. And as scientists, biologists, and engineers, is evidence optional? Or is it must have?
Must have.
Must have. Now you're going to learn more about how different animals see in low light and in high light. Okay? So we're going to be playing with the different kinds of lights. And to do that, guys, we're going to use your modeling tool, which you've already used. They're going to look a little different from the ones that you did before. It's going to look the same way. It's going to be really important. We're going to do high and low sensitivity, and then two different kinds of light. So we'll be doing two different modeling tools today, okay? And another thing is, I want y'all to go ahead and see this, is that we're gonna be doing a moth, and I want you to see what that looks like. I don't know where it is. Okay, in case you didn't know what a moth is, this is a moth. Okay, hands down. And we're gonna be looking at a moth, but when you look at this modeling tool, let's go back to it real quick. Do you see that anywhere on there? No. So you're going to be looking for a shape to appear that looks like a moth. Maybe. Okay, because we're going to be looking at different kinds of lights. Okay, you're going to work with your groups. And it says on the slide that you're going to be working with groups of 4. Is there anyone in here who has more or less than 4? Okay, so suggest, what are we going to do if you only have 3? Say that again. Okay, perfect. I think that's the best solution. Instead of one person by himself, I would rather work all together. Okay? So what you're going to do is you're going to be working in your groups, but within your group, you're going to form off in partners. Okay? So everybody look at your group and point to your partner. Very good. Now, your table, I have to have one group that's doing high and one group that's doing low. So talk at your table and decide. Y'all want low and y'all want perfect. So that this is your thing. This is just so you don't forget. What are y'all doing? Okay. Leah, tell me what you learned about high sensitivity yesterday.
High sensitivity means that you can see well in the dark, I'm pretty sure.
Very good.
I would like to add on to Liam by saying, because he said that you can see well in the dark. Is that what you said?
High sensitivity, he did. He said he can see well in the dark.
And that I would like to add on by saying, another way to say it is, you don't need that much light for high sensitivity.
Good.
Volume.
I agree with what you're saying. I'm going to dig for this. I want you to tell your partner, because you and your partner did two different things, right? You had the same kind of what? Sensitivity receptors, but you had different kinds of light. So if you had different kinds of light, the same kind of receptors, will you see the same thing? No. So I want you to tell your partner who has the same kind of receptor that you have, what you see, if you can see, why you can see, or why you can't see.
Okay, so I can see the moth because there's a lot of light. So I think it's an abnormal creature. And I think mine is, and since mine has low sensitivity receptors, mine has low sensitivity receptors and low light, and it's very dark in my picture, so I can't see anything no more.
Low sensitivity light receptors are meant for more light, and they're meant to take in more light. But since this is low light and it has low sensitivity light receptors, that means that it's kind of uneven. It won't work as well because a little bit of light and sensitivity light receptors that need more light, it doesn't go so well.
For absolutely 100% complete answers. If you hear an answer that's not all the way complete, what should you do? You should, because we're trying to get, remember, you're the scientist. We need full explanations. Remember, you're preparing to build a model for your conservation group to explain this tokay gecko situation. Okay, so we need full explanation so that we can build a full model. All right, first person that I want to share is Mr. Riggers. What did you say?
I said that low sensitivity light receptors since they need more light to come in, so it'll be a clearer image to the brain, they need more light.
Low sensitivity light receptors. How does this explain why the squirrel sees well during the day, but not as at night? Think. Right. This is your eyeball. Remember? What part's the pupil? What'd you say to pupil? Why?
The pupil is something, actually a hole that looks diagram.
Okay, good. So we know that. So find something else. What y'all got going on over here?
We figured out what everything is. So this will be the pupil, and this will be the light receptor.
The what?
The light receptor.
Do you have one light receptor? Think about the simulation that you saw.
We have more than one.
Okay.
This would also
Go ahead. What were you going to say?
this would be what did you say? The light receptor. This would be the optic.
Okay, and so that's going to connect what to what?
The brain.
So what's your brain?
The brain is this.
Ah, I like that.
And that's the eyeball. Okay, hold on.
What has to go into this?
Oh, this is
We can do this. Yeah, we can do that, put it in the box, and then we can make the...
All of the lesson objectives were met. I know because of the students' rich discussion that they know why animals see differently in different kinds of light. Also, students were able to plan very carefully and very diligently what their model will look like. And as they presented that plan to the class and they got feedback, they were very successful. When thinking about what I would do next time, there's so much I could do and so much I should do because I know my students and myself can always be better. After the segment of the video that you saw today, students actually presented their plan to the class, and their classmates gave feedback based on the guidelines of the vision model. Tomorrow or the next day, what they would actually do is build their model.